In this video we're going to go through some functions questions from the Junior Cert Ordinary Level Leaving Cert. This question says the amount in appropriate units of a certain medical drug in the bloodstream after T hours after it has been taken can be estimated by this function. So basically, when you take a drug, it takes a while for it to get into your blood system, and then it takes a while for it to leave your blood system. This function will tell you how much of that drug is in your blood system after 1 hour, 2 hours, 3 hours, whatever. Use the drug amount function to show that the amount of the drug in the bloodstream after 4 hours after use the drug amount function CT to show that the amount of the drug in the bloodstream 4 hours after the drug has been taken is 224 units. Okay, so all we'll do is we'll put 4 in for the time. Okay. And when I throw that into the calculator, I will get 224. So that's after proving that. Use the function CT to complete the table below. Okay. So I put in 0 for T, and I get 0 amount of the drug. That makes sense, yeah? Before I take the drug, 0, that's 0 hours. I won't have any amount of the drug in my system. 1 hour after I take the drug, so if I put 1 in for T, I get 57.5 whatever units of the drug in my blood system. I now need to put in 2 in for T and see what it spits me out. And when I put in 2 into my function and work it out on my calculator, I get 118. When I put 3 into my function in place of T and work it out, I will get 175.5. Again, I've done this already. When I put in 4 into it, I got 224. If I put in 5 into it, I get 257.5. And 6 into it, 270. 7 into it, 255.5. 8 into it, 208. And 9 into it, 121.5. So if you notice, after we've taken the drug, the amount of the medicine or the drug that's in our bloodstream increases and then it decreases, and that makes sense. Yeah, you take a tablet, it takes a while for it to kick in, and then it takes a while for it to, I suppose, get out of your system. Draw the graph of the function. Okay, well, here's the time down here, and here's the amount of drug. So if I look up here, my pints will be 0, 0. It's the first one, so that'll be down here. Next will be 1 and 57.5. So 1 and 57.5, which is about here. Next then is 2 and 118 here. The next one is 3 and 175.5 here. Next is 4 and 224. 224, so a little bit underneath, barely. 4 and 224, yeah. 5 and 257.5. 257.5 is about here. 7 then is 270, so that's about here. 7 then is 7 then is 255.5, which is about here. 8 is 208, and 9 is 1.5, so 1.5, so we're talking about here. So just do my curve again, not with a straight line, it has to be curved. It could be dot marks. So now we're going to use our graph to estimate or to solve these questions, answer these questions in part D. It says use your graph to estimate each of the following values. In each case, show your work on the graph above. So we're going to find the amount of drug in the bloodstream after 3.5 hours. So we go to 3.5, we draw a straight line up, we go across, we get 200. How long after taking the drug will the amount of drug in the bloodstream be 100 units? Well, we go to 100 units, so we go across, alright, down, and it's 1.75 hours, which is 1 hour 45 minutes. So 1 hour 45 minutes. Okay. Use the drug amount function to find, in terms of t, the rate at which the drug amount changes after is changing after t hours. Rate of change. Okay, straight away you should that should be an alarm bell for you. It's differentiation. So it's minus 3t squared plus 9t plus 54, and that is dc dt. Okay, so there's our differentiated formula. Use your work in part EI to find the rate at which the drug amount is changing after 4 hours. Okay, so we take this new function and we put in 4. So minus 3, 4 squared plus 9, 4 plus 54. And we get 42 units per hour. Okay, the next part of the question says, use your answer in part EI to find the maximum amount of the drug in the bloodstream after 9 hours. Okay, so, well, our answer to part E is minus 3t squared plus 9t plus 54, and that's dc dt, isn't it? Right, so I want to find the maximum amount. As soon as you hear maximum, you differentiate, you let equal 0, and you solve. We're after differentiating the function. There it is. We let it equal 0 and we solve. So minus 3t squared plus 9t plus 54 equals 0. I could throw that into my minus b formula and see to find out what t is, but I'm going to simplify it a bit further. I'll change my signs the whole way across. And I can divide across by 3. Now, I can factorize this out. There's no need to use my minus b formula. You can if you want, but personally I just find it a bit long and tedious. So if I can factorize it, I will. T numbers that multiply to give us 18. 6 and 3 will do it for me. Minus, plus. Let both of them equal 0. 0. T equals minus 3. T minus 6 equals 0. T equals 6. Right, so I have two answers here. The time is minus 3 hours and the time is 6 hours. I can't have a minus 3 hours, right? So now it's saying that after 6 hours, the drug is at its maximum amount in my body. But they don't ask me when the maximum amount is. They ask what the maximum amount of the drug is. So I'm going to have to take that 6 hours and put it back in to my formula. Okay, and that will give us minus t cubed plus 4.5 t squared plus 54 t. That was my original formula. So now if I put 6 in for this, I should get back out 200 270 units of the drug. Okay, so if we're back in the original formula, and after 6 hours I get this much of the drug. So that's the maximum amount of drug is going to be in the system. Okay, so last question in this. Use your answer in part EI to show that the drug amount in the bloodstream is decreasing after 7 hours. Okay, so we're looking at increasing and decreasing. So we're thinking of rate of change. Okay, rate of change, is it increasing or is it decreasing? So I'm going to look at my rate of change formula, i.e. the differentiated formula. Okay, and there it is. Now, if I put in, let's say, a 7 in for T, and if it spits me out a positive value, that means the rate of change is positive, which means the amount of drug in my system is going up the way at that time. However, if I put in 7 hours and there's a minus value, well, that means at 7 hours the amount of drug in my system is going down the way. Okay, because I'm looking at positive rate of change versus negative rate of change. So put in 7 here, minus 3, 7 squared plus 9, 7 plus 54, and that'll give me minus 30 units per hour. So that means it's decreasing by 30 units per hour. So that means it is decreasing. Okay, the amount of drug in my system is decreasing at this stage at 7 hours. So the explanation, well, the rate of change is negative, therefore the amount of drug in the blood system is decreasing, okay, at or after 7 hours. Okay, and that kind of makes sense, right? You take a tablet, it takes a while for it to kick in, the amount of tablet or the amount of drug in your blood system would increase, and then after a while it would start decreasing again. Okay, I mean the drug would leave your system. Okay, thanks.